In this video, we are going to solve some topical past paper 2 questions randomly selected from the topic standard solution. But before we continue, I really want to appreciate those of you who have subscribed to our channel. And for those of you who haven't subscribed to our channel, we are not asking you to donate or to buy pamphlets. We are more interested in your success. What we are mainly asking you to do is to subscribe to our channel, like our videos, and share to fellow learners. Let's get started. What do you understand by a standard solution? As you know, a standard solution is a solution containing a precisely known concentration of an element or a substance. For instance, a known mass of a solid is dissolved to make a specific volume. Standard solutions are used to determine concentration of other substances. So that is just a word about standard solution. Is a solution containing a precisely known concentration of an element or a substance. I was saying that, for instance, a known mass of a solid dissolved to make a specific volume. So that is how the whole thing is. So as we'll be starting with question number one. Question number one, explain how you would prepare 60 cm cube of aqueous solution of silver nitrate of strength 0.030 gram silver nitrate per cm cube. Explain how you would prepare 60 cubic centimeter of aqueous solution of silver nitrate of strength 0.030 gram silver nitrate per centimeter. Okay, how are you going to prepare this? How are you going to prepare this standard solution? How are you going to prepare this? But you should know that each centimeter cube of solution will contain 0.03 gram silver nitrate. Each centimeter cube will contain what? Will contain 0.03 gram of silver nitrate. Therefore, 60 cm cube will contain what? How much will 60 cm cube contain? That is the thing. How much will 60 cm cube contain? 60 cm cube will contain what? Will contain 0.030 gram times 60. Times 60, and which will be equal to what? 1.8 gram silver nitrate. That is the simple way you can do it. Or since you have been given the volume, if you don't want to take this, since you have been given the volume of the volume, and you have been given the mass. You are given the volume and the mass. Now we need to convert the mass to what? We need to convert the mass to moles. We need to convert the mass to moles. Now, what would be that is method two. You need to convert the mass of silver nitrate to moles. So what you need to do is that you will look for the molar mass of silver nitrate, then divide 0.03 gram of silver nitrate over all over the molar mass. You have the number of moles of silver nitrate. When you have the number of moles of silver nitrate, now we need what? We need um, we need 60. We need to prepare 60 cm cube. You have got the number of moles, and there is a formula that the mass, I mean the molar mass equals. Welcome back. As I was saying, I said we already have the by when we divide 0.03 gram by the molar mass of silver nitrate, we will have the number of moles of silver nitrate. Now, there is a formula that the mass is equal to what? Moles times the molar mass. Moles times the molar mass. So now, since we have the number of moles and we know the molar mass of silver nitrate, to have the mass that will be dissolved, we will multiply the number of moles by the molar mass and we'll have the mass. And the mass will be 1.8 gram of silver nitrate. We now take the silver 1.8 gram of silver nitrate. We dissolve in about 50 cm cube of water in a beaker. We can dissolve in a beaker of 60 centimeter cube. But now we put 50 cm cube in that beaker of distilled water. Then put in the 1.8 gram of the silver nitrate. Dissolve it very well. You can use the glass rod to dissolve it very well. Then when it has all been dissolved, you can now add sufficient distilled water to make the volume exactly 60 cm cube. The stirring will ensure uniformity in the solution. There are two methods I've given you. I said the first method is, since each centimeter cube of solution contains 0.0330 gram of silver nitrate, then 60 cm cube will contain what? 60 cm cube will be just cross multiplication. It will be 0.03 times 60. We will have that mass. That is just all. Or method 2, you have been given the mass. Divide the mass by the molar mass of silver nitrate. You have the number of moles of silver nitrate that are going to be dissolved. To have the mass, because you need to measure by the silver nitrate salt, to have the mass now, you will now multiply the moles by the molar mass of silver nitrate. You have the mass. Then you measure exactly 1.8 gram dissolved in about 50 cm cube of distilled water. When it is fully dissolved, you add sufficient water to make the solution to 60 cm cube, and that will be all. Question number 2. Question number 3. One mass of ammonium sulfate is required to prepare. 1 mass of ammonium sulfate is required to prepare 400 cm cube of M all over, that is molar, 1/4 molar solution. 1/4 molar solution. 1/4 molar solution is exactly as 0.25 molar. 1 mass of ammonium sulfate is required to prepare 400 cm cube of 1/4 molar solution. You know that what we need to do here is we need to use what we are going to use here is we need to use the 2 triangles. The first triangle here we need to do is we need to look for the concentration. We need to look for the concentration. However, method number 1, the first method is remember that this molar M all over 4 is 1/4 a molar solution, which is equal to 0.25 molar. And the molar mass of ammonium sulfate is 132.1. 132.1. Now, what we are going to do now is, if 1000 cm cube of 0.25 molar, that is the molar, that is M all over 4. If 1000 cm cube of 0.25 molar solution will contain this mass, it will contain 33.02 gram. How do you get the 32.02 gram? It is the molarity, that is this times 132.1 gram. So now, so what we do now is, if 1000 can contain this, therefore 400, because we have been asked to prepare 400 cm cube of 0.25 molar will contain 33.02 times 400 divided by 1000. We will have 13.2 gram of ammonium sulfate. Method number 2 to solve this one is this. Concentration from this triangle here, concentration, you have this, we have the number of mole, concentration is equal to moles divided by the volume in dm cube. Therefore, the number of moles will be what? Moles now will be equal to concentration times the volume. Now we have been given the volume. The volume is 400. The volume is 400. 400 divided by 1000. 400 divided by 1000, we will have 400 divided by 1000. We will have 0.4. We will have 0.4 dm cube. Then 0.4 dm cube. We want to have the number of moles. So now 0.4 dm cube times the molarity. The molarity is what? Is 0.25 because it is 1/4 molar. 0.25. So 0.4 times 0.25. We will have 0.1. We will have 0.1. Then 0.1, that will be the number of moles. That will be the number of moles. Then we are told the molar mass of ammonium sulfate is 132.1. Excuse me. So now we are still going to use the other triangle that says the mass will be equal to what? The moles times the molar mass. Mass is equal to moles times molar mass. So now let's multiply the moles 0.1 times the molar mass is what? The molar mass is 132.1 times 132.1. We will have 13.21. We will have 13.21. That is method 2. That is method 2. And that is method 3. This is method 2 and that is method 3. I said method 3 is the easiest one. You have been given the volume. You have been given the molarity. So what you need to do is what? What you need to do here is, now the moles will be equal to concentration times the volume in dm cube. Convert the volume by dividing it by 1000. Convert the volume by dividing it by 1000. It will give you 0.4 dm cube. 0.4 dm cube times 0.25 molarity. You have 0.25 molarity. You have 0.1. And then 0.1 now you multiply it by what? By the molar mass, which is 132.1. 0.1 times 132.1. We will have 13.21. This is the required mass. This is the required mass that is used to prepare a solution of 400 cm cube, a solution in 400 cm cube of 1/4 molar solution. So you will need 13.21. Very simple. All the things I'm giving you are very, very important. We will go now to question number 4. Question number 4. Question number 4. Question number 4 now has to do with how many grams of potassium manganate are needed. Potassium manganate, or we call it manganate 7, are needed to make 500 cm cube of 0.25 molar solution. How many grams? Now we have been given the volume. We have been given the molarity. That will be method number 2. Let's start with method number 1. Having known the molar mass of potassium manganate 7, what we need to do is, if 1000 cm cube of 0.25 molar contains what? Contains 0.25 times 158. 0.25 times 158. That is 0.25 is the molarity times 158. So 0.25 times 158 will give us 39 point this. This is what is already in here. If 1000 cm cube can contain this one. Now, how much would 500 get? Therefore, 500 cm cube of the same 0.25 molar solution will contain 500 times 39.5 divided by 1000. You will have that. Method number 2. Method number 2, we are going to use the triangle now and other ones. Now, method number 2 now is, we need to have the number of moles. We need to have the number of moles. We have been given the concentration, which is 0.2 molar. The volume is what? The volume is 500. So 500 divided by 1000, it will give us 0.5. It will give us 0.5. Now, we want the number of moles. So in order to have the number of moles, multiply the concentration by the volume in dm cube. So we have 0.5 dm cube. 0.5 dm cube times what? Times the concentration, which is the concentration is 0.25 times 0.25 times 0.25. We will have 125. We will have 125. That will be the number of, that will be, we will have 0.125. 0.125. Those are the number of moles. But the mass is what? In the other triangle which I showed you, the mass is what? Mass is, to have the mass, we will multiply, to have the mass, we will multiply the number of moles by what? By the relative atomic mass or by the molar mass. It depends what you are using. So the molar mass is 158. So 0.125 times 158 times 158. We will have 19.75. We will have 19.75. So our mass that is required, how many grams of this are needed to make this? So the mass that is required, or the gram that is the mass that is required to make 500 cm cube of 0.25 molar solution is 19.75 gram of potassium permanganate. It takes us to question number 5. Question number 5. Question number 5. How many grams of each? How many grams of each solid are present in 25 of each solid, that is, are present in 25 cm cube of a solution which is 0.4 molar sulfuric acid, and the other solution is what? 0.75 molar of iron 2 sulfate. Iron 2 sulfate. Now, what you need to do here is this. For question number 1, the simple thing we will do, the method the first method is usually if 1000 cm cube of 0.4 molar. If 1000 cm cube of 0.4 molar will contain what? Will contain a certain mass. And the mass is what? The mass is always the mass is always 0.4 times the molar mass. 0.4 times the molar mass, which is 39.2. So if 1000 cm cube of 0.4 molar will contain the mass will contain 39.2 gram of sulfuric acid. Then the volume that was what? Then 25 cm cube of this same solution, that is of 0.4 molar solution, will contain what? Is 25 times 32 divided by 1000. We will have 0.98. That is by simple proportion, you have 0.98. Let's go by formula. Let's go by formula now. By formula, you have been given the volume and you have been given the molarity. The only thing we do is what? Divide the volume into, convert the volume into dm cube. And if we convert the volume into dm cube, that is by dividing 25 over 1000, we will have 0.025. Then 0.025, we want to look for the number of moles. So the number of moles will be what? 0.025 times the molarity, which is the molarity or the concentration, which is 4. So 0.025 times 4, we will have 0.01. It will be 0.01. That will be the number of moles. Now we have the number of moles, which is 0.01. To have the mass, let's multiply this 0.01 times the molar mass. The molar mass is 98. 0.01 times 98, we will have 0.98, the same thing. Once more, for method 2, I said you have been given the volume and you have been given the molarity. Use the triangle which says the triangle which says the number of moles will be equal to what? Concentration times the volume in dm cube. So convert the volume into dm cube. It will be 0.025 times the concentration, which is 0.4. We will have 0.01. The molar mass of sulfuric acid is 98. Then the mass will be what? The mass will be the moles times the moles times the molar mass. The mass that we are looking for will be moles times molar mass, which is 0.01 times 98. You have the answer, which is 0.98. It takes us to question number. Okay, the second part of it, which is iron 2 sulfate. It's the same thing. Let me just go to method number 2. It's the same thing. You have been given, for iron, you have been given the molarity as 0.75. The volume still remain. So what we will do for iron, and the molar mass for iron is 152. So what you will do for iron is convert the volume to what? To dm cube, and it will still be 0.025. It will be 0.025. Now let's look for the number of moles of iron. The number of moles of iron will be the number of moles will be the volume in dm cube times what? Times the molarity, and the volume will be what? 0.025. It will be 0.025. It will be 0.025 times the molarity is what? Molarity is 0.75 times 0.75, and we had 0.01878. I mean 0.01875. 0.01875. Those are the number of moles of iron 2 sulfate. But we are looking for the mass. And in order to have the mass, we multiply this number of moles by the molar mass of iron 2 sulfate. And the molar mass of iron 2 sulfate is what? 152. Let's multiply it by 8. Times 152 times 152. We will have 2.85 gram. 2.85 gram of iron 2 sulfate. So let's go to the next question. Question number 6. Question number 6. Question number 6 says. Question number 6 says 225 cm cube of a saturated solution of a substance was evaporated to dryness, and the residue had a mass of 2.56 gram. What was the molar concentration of the saturated solution? What was the molar concentration of the saturated solution if the molecular mass of the substance is 148? Simple. Very, very simple. You have been given the mass. You have been given the mass. You have been given the volume, and you have been given the molecular mass. So what we want is the molar concentration, the molarity or the concentration. So the first thing in this thing is you can use the formula, which is mass equals to molarity times molar mass times volume in dm cube, and then make molarity the subject, and you have your answer. If you use that and make molarity, that is mass equals to molarity times molar mass times volume in dm cube, and make molarity the subject, you will have your answer. If you don't want to use that, method number 2 is let's look for the number of moles for this saturated solution. let's look for the number of moles of this saturated solution. The number of moles for this saturated solution is that we have been given the mass. We have been given the mass there. So the number of moles will be what? The mass divided by the molecular mass, which is 148, and the mass is 2.560. So we will divide 2.560 by 148. We will divide 2.560 by 148. We will have the number of moles, and the number of moles, it will be what? Will be 0.173. It will be 0.0173. 0.0173. That will be the number of moles of the saturated solution. Now, concentration is equal to what? Concentration, we are looking for the molar concentration. Concentration will equal to what? It's equal to moles divided by what? Divided by the volume in dm cube. Moles divided by the volume in dm cube. Since we know the volume to be 25, we already have the moles. We have already divided the mass by the molar mass, and we have got the number of moles to be 0.0173. Now we want the concentration. We will divide the moles by the volume in dm cube, and let's convert the volume in dm cube. 25 to dm cube, 25 cm cube to dm cube will be 0.025. Therefore, our concentration will be what? 0.0173 divided by 0.025. 0.0173 divided by 0.025. Our concentration will be 0.692 mole per dm cube. Either you say 0.692 mole per dm cube or 0.692 molar. That is how you get it. So that is how you can easily get your answer. Question number 7. Question number 7. How many grams of question number 7. How many grams of 5%? 7. How many grams of 5% sodium chloride are necessary to yield 3.2 gram sodium chloride? You know, 5% of sodium chloride will contain 5 gram. 5% of sodium chloride, that is 5 gram in 100 gram of solution. That is just simple. 5 gram in 100 gram of solution. 5% of sodium chloride solution. That is it will be 5 gram of sodium chloride in 100 gram of solution. However, if 5 gram of sodium chloride is contained in 100 gram of solution, therefore 1 gram of sodium chloride will contain what? It will contain 100 gram divided by 5. 100 gram divided by 5. And 100 gram divided by 5. Then in 3.2 will be what? Times 3.2. The answer is there, just there. 100 divided by 5 you will have for 1 gram. 100 divided by 5 is 100 divided by 5. You will have 20. You will have 20. That is for 1 gram will contain will be contained in 20. 1 gram of sodium chloride will be contained in 20 gram of solution. Then in 32 gram sodium chloride we what? Times 32. So 20 times 3.2 is what? 20 times 3.2. Our answer will be 64 gram in solution. Simple. Let's move to the next question. Question number 8. Question number 8 has to do with neutralization. We are told how many cubic centimeter of 0.6 molar sodium hydroxide are required to neutralize 30 cm cube of 0.4 molar hydrochloric acid. I told you in this acid-base neutralization or titration, the first thing you do is you have to write your balance equation. And a balance equation has been written. 1 mole of sodium hydroxide reacts with 1 mole of hydrochloric acid, standard. Since 1 mole of sodium hydroxide is reacting with 1 mole of 1 mole of sodium hydroxide is reacting with 1 mole of hydrochloric acid, what we need to do is we will equate the number of moles of. What you will do here is equate the number of moles of the alkali, that is sodium hydroxide, equals to the number of moles of hydrochloric acid. Let's calculate the number of moles of hydrochloric acid. We have been given the volume of hydrochloric acid. We have been given the molarity. To calculate the volume of hydrochloric acid, we will do what? Convert the volume to dm cube. And when we convert the volume 30 to dm cube, it will be 0.03 dm cube. And when we multiply by 0.4 to have the number of moles, it will be 0.012 moles of hydrochloric acid. It will be 0.012 moles of hydrochloric acid. Then let's calculate the number of moles of sodium hydroxide. Now we need to do what? We need to multiply the volume. We need to multiply the 0.6 times the volume in dm cube to have the moles. So now 0.6 times volume in dm cube equals to 0.012. Let's make volume in dm cube the subject. So we will divide now 0.012 divided by 0.6. We will have our volume in dm cube of the sodium hydroxide. Once more, since 1 mole of sodium hydroxide is adding 1 mole of hydrochloric acid, we will calculate the moles of hydrochloric acid and calculate the moles of sodium hydroxide. And there, now in sodium hydroxide will be lack of the volume. So for sodium hydroxide, it will be 0.6 times volume in dm cube, which will be equal to the moles of hydrochloric acid, which will be 0.012. Now that we are looking for the volume in dm cube for sodium hydroxide, we make volume in dm cube the subject. So we will divide all side by 0.6. So it will be 0.012 divided by 0.6, and it will give us what? 0.2 dm cube. Either we'll call it 0.2 dm cube or 20 cm cube of the sodium hydroxide is required. Method number 2. Since we have everything for hydrochloric acid, the molarity and the volume, for the acid, for the alkali, we have only the molarity, we don't have the volume. Then the mole ratio, we have 1:1 from our balance equation. We can use the molarity, the formula, molarity of MAVA divided by MBVB equals to the mole ratio, which is A all over B. We will substitute molarity of the acid times the volume of the acid, volume of the acid divided by the molarity of the base times the volume of the base, and everything will have the answer. That is it. We just have the answer there. We have the answer there. So that is it. Either use method 1 or use the formula, you have the answer. Let's go to question number 9. Question number 9. Question number 9 has to do with question number 9. It has to do with some I think it's red dog titration, something like that. Question number 9. 0.015 0.0155 molar potassium manganate 7 solution was used to titrate a sample of an anhydrous divalent metal sulfide, and 0.1120 gram reduced, that's gram of the disulfide, metal disulfide, reduced 27.75 cm cube of the potassium manganate 7 solution. What is the molecular mass of the metal sulfide? Wow. It's very simple, very, very simple. The first important thing is you must know how you can write your red dot equation. The red dot equation for the metal sulfide, for the sulfide and manganate 7, acidified manganate 7 ion. So writing your redox equation is very, very important. If you can write the redox equation for the sulfide and the acidified manganate 7 ion, then you are halfway gone. Because after writing the equation, the next thing will be, after writing the equation, see the next step. Now, the next step here we are going to do here is this. We are going to calculate the number of moles of potassium permanganate. We are going to calculate the number of moles of potassium permanganate. And the number of moles of potassium permanganate is that we have been given the molarity. We have been given the molarity to be 0.0155, and we're given the volume. So that volume, we have converted the volume to 1000. That is 27.27, which was 27.27 divided by 1000. I think I need 27 point something like that. We have converted the volume. We have now converted the volume to dm cube. So the volume to have the moles is the molarity, which is 0.0155 times the volume. I am using the triangle there. If I multiply the molarity times the volume in dm cube, I will have 0.00043 moles. Those will be the number of moles of potassium permanganate. Now, those are the number of moles of potassium permanganate. Now, we have to use the number of moles of potassium permanganate to calculate the number of moles of the sulfide. So, from the equation, see how I am doing it. From the equation, from the balance equation, 5 moles of the metal sulfide react with 2 moles of potassium permanganate. Therefore, how many moles of the metal sulfide will react with the moles of that we have just calculated, 0.0043 moles of potassium permanganate? When we do that, it will be the number of moles of a metal sulfide will be 0.0043 times 5 divided by what? Divided by 2. And the number of moles for the metal sulfide will be what? It will be 0.001 moles. We will have 0.001 moles of the metal sulfide. Remember that you will have from the triangle, from the other triangle, The molar mass is equals to what? The molar mass is equals to what? Is equals to the mass divided by the number of moles. We're given the mass to be what? To be 0.1120 gram. We're given the mass to be 0.112 gram. And the number of moles that we calculated for metal sulfide is 0.001. So to have our molecular mass of the metal sulfide, we divide the mass that was given by the moles of the metal sulfide. And when we divide 0.1120 by 0.01, we will have 112 gram per mole. That will be our molecular mass. I said in such equation, the first thing is you must write your redox equation. After writing the redox equation, look for the other one, one of the reactants. Whether is it the look for the one that all the information have been given. You calculate the number of moles, and then after calculating the number of moles, you use the number of moles of that one to calculate the number of moles of the other one. We calculate the number of moles of potassium permanganate by using moles equals to molarity times volume in dm cube. After using that, we use now our equation. Use our equation, our balance equation, and the number of moles that we have just calculated to calculate the moles of the second one. As I said, if 5 moles of this can react with 2 moles from our balance equation, then how many moles of the metal sulfide will react with the calculated moles of potassium permanganate? We will have the number of moles. Then remember that molar mass is equal to mass divided by the moles. When we divide the mass by the number of moles, we will have our molecular mass. It takes us to question number 10. Question number 10 is the same thing, the same procedure. Question number 10. 0.51 gram of sodium thiosulfate was dissolved and made up to 250 cm cube. This solution was used to estimate an iodine solution. 25 cm cube of this thiosulfate solution reacted with 18.62 cm cube of iodine. Calculate the molarity of the iodine solution. The first thing is you need to write your equation. You need to write your equation. From your equation, you will see that 2 moles of the thiosulfate reacted with 1 mole of iodine. 2 moles of the thiosulfate reacted with 1 mole of iodine. And then we will say if 1 liter of 1 molar, that is, if 1 mole of iodine solution reacted with 2, that is 2 times 246 of sodium hydrated sodium thiosulfate, then how many moles of the iodine will react with that? You will calculate the number of moles of the iodine. After calculating the number of moles of iodine, but 0.00102 moles of iodine are in 18.62 cm cube. Therefore, X of iodine will be in 1,000. Simple proportion, and you get the answer, and that will be it. It will be 0.00102 moles times 1,000 divided by 18.62. You have 0.00547 molar. But it should be noted, quite alright, that standard solution of bases and acid, the standard solution of sodium hydroxide and potassium hydroxide cannot be prepared directly by just weighing and dissolving the substance in solution, because they are hygroscopic and cannot be weighed accurately. What is usually done is to weigh an approximate amount of the appropriate quantity of any of them and dissolve it in distilled water. We'll go to question number the B part of it. How many grams of sodium chloride are needed to make 500 cm cube of molar solution? I think that is another one similar to what we did. How many grams of sodium chloride are needed to make 500 cm cube of molar solution? It's very simple, very, very, very simple. How many grams? Okay. It is simple. Method number one. Let's use this method before. We go to formula. This method is the molar mass of sodium chloride is 58.5 gram per mole. We can now say if 58.5 gram of sodium chloride produces 1 dm cube of solution, right? If 58.5 gram of sodium chloride produces 1 dm cube or 1000 cm cube of molar solution, therefore x gram of sodium chloride will produce 500 cm cube of molar solution. Simple, very simple, very, very simple. How many grams? Very simple. That's the only way, that's the only thing you can do here. If 58.5 gram of, which is the molar mass, can, because that's 1 mole, that is 1 mole of sodium chloride. That is 1 mole of sodium chloride. If we dissolve in 1000 cm cube or in 1 dm cube, that is a standard solution of it. That is a molar solution. So if we say if 58.5 gram of sodium chloride produces 1 dm cube or 1000 cm cube of molar solution, then what will be the amount in 500 cm cube? It's just a cross multiplication. 500 times 58.5 divided by 1000. You have the answer right. I think we have come to the end of this, but before I go, I want to remind those of you who have not subscribed to our channel. It is for your interest. Advise those who will be sitting for the exam next year or in 2 years' time. Advise them to subscribe. While you are subscribing to our channel, advise those who will be sitting for the exam next year to also subscribe, because our main goal is that you succeed. We are more interested in your success. Once more, like the video and share to other learners. Thank you for listening. Wishing you best of luck in your exams.